There's a great white shark gliding through open water, and stuck to its belly is a fish the size of your forearm. Not stuck, choosing to be there. And according to a 2020 study, it's steering. This is the remora. It has been riding apex predators for 50 million years, and we only just figured out what it's actually doing. To understand what the remora is doing, you first have to understand what it is. It's small, 12 to 18 inches, no venom, no claws, no camouflage, no teeth worth mentioning. By every measure that matters in the ocean, it should be dead. But it has one thing, one single evolutionary trick. On the top of its head, where a dorsal fin should be, there's a disc, not a fin, not a sucker, a ribbed, oval-shaped pad of modified tissue that functions like a biological vacuum seal. That disc can hold 40 times the remora's body weight. A sailfish can hit 68 miles per hour. The remora holds on. It can detach and reattach in under 1 second at full speed, mid-water. And here's where it gets strange. That disc didn't come from nowhere. It evolved from a dorsal fin, the same fin every fish has on its back. Over roughly 50 million years, that fin migrated to the top of the skull and restructured itself into a suction device. A 2022 genetic study confirmed it happened in a single rapid evolutionary event. One burst, one transformation. The animal essentially rebuilt its own face to become a passenger. The Romans were so disturbed by this fish, they named it Echeneus, the ship stopper. Pliny the Elder wrote that a remora latched to the hull of Mark Antony's flagship at the Battle of Actium and held the ship in place. That's mythology. But the instinct behind it, that this small fish could exert that kind of control over something massive, that part turns out to be surprisingly accurate. Here's the thing though, if the remora is just catching a free ride, why does it keep moving? Studies show it repositions constantly, belly, flank, gill slits, even inside the mouth of a whale shark. That's not a hitchhiker getting comfortable. That's something with a destination. And there's a second question nobody could answer for a long time. Why does the shark let it? In 2020, a biologist named Brooke Flaming at the New Jersey Institute of Technology decided to actually find out what the remora was doing. Not from a boat, not from a cage. She attached tiny cameras directly to the remoras themselves, and what she watched changed the entire framing of this animal. The remora wasn't drifting, it wasn't resting, it was working. It slid, deliberately, methodically, from the shark's flank toward the gill slits, then down toward the cloaca, then back up. These are the two places on a shark's body where material exits: waste, scraps, parasites loosened by water pressure. The remora was mapping the shark like a maintenance worker who knows exactly which pipes leak. It wasn't waiting for food to come to it. It was positioning itself where food was guaranteed to appear. That answers the first question. Why it keeps moving? It's not restless. It's hunting. On the surface of a living animal, at full speed, in open ocean. But here's where it gets strange, because to do any of this, the remora has to solve a problem that, until recently, human engineers could not. How do you stay attached to a surface that's constantly flexing, accelerating, and changing shape without using any energy to hold on? Sailfish hit 68 miles per hour. The remora holds on, not gripping, not muscling through it, just attached. The disc on top of its head is the answer, and it is one of the most sophisticated adhesion structures ever studied. It's a modified dorsal fin, the same fin that runs along the back of most fish. On the remora, it migrated forward over millions of years and flattened into a suction pad. But calling it a suction cup undersells it completely. Inside the disc are rows of fin rays, each tipped with tiny backward-facing spines called spinules. When the remora presses down, those rows create a pressure differential. Lower pressure inside the disc, higher outside. The result? The disc holds 40 times the remora's own body weight, passively. No muscle required. And when it needs to move, it detaches and reattaches in under 1 second, at speed, mid-swim. In 2019, the biomechanics lab at Harvard took the disc apart to understand exactly how it worked. They weren't writing a nature paper. They were trying to solve an engineering problem. Underwater drones lose adhesion on curved, wet, moving surfaces. They always have. It's one of the core limitations of underwater robotics. The remora solved this 50 million years ago. Harvard used the disc architecture as the direct blueprint for a new generation of adhesive drone technology. A 12-inch fish handed aerospace engineers a solution they'd been chasing for decades. That's turn 2. The disc isn't just impressive, it's patentable. Now, here's turn 3, and this one is going to make you look at the whole relationship differently. We said the shark tolerates the remora. That's the standard line. Mutual benefit. Remora eats parasites and dead skin. Shark gets a cleaning service. Nobody gets eaten. But new tagging data is pointing at something much weirder. Researchers tracking both animals simultaneously notice something in the movement patterns. When a remora repositions, shifting its body weight from one side to the other, the shark's heading sometimes changes. Not dramatically, not a hard turn, a drift. A subtle correction in swimming direction. The hypothesis being tested right now, a 12-inch fish, by redistributing its own mass on the surface of a 2,000-pound predator, may be able to influence where that predator goes. Not controlling, not commanding, nudging. Think about what that means.
Shark.
The
Let's learn its
remora
body parts.
positions itself near
These are
food
its
sources
gills.
on the shark's
This
body.
is its belly.
It's already
And
demonstrated
this is
it
its
understands
flank.
the shark's anatomy
This
better
is a
than
shark.
most animals
Let's
that
learn its
interact
body
with
parts.
sharks. And now it may be able to gently, incrementally steer toward better feeding grounds. The shark doesn't know. The shark has no reason to suspect the small fish on its back is doing anything other than eating parasites. But the remora might be the most sophisticated freeloader in the ocean. Or it was never freeloading at all. That question, what the shark actually gets out of this, and whether this is even a one-sided relationship, that's where this gets really uncomfortable. Here's the number that stopped researchers cold. The remora's disc can hold 40 times its own body weight. Not 40%, 40 times. A remora weighing half a pound can grip with the force of a 20-pound anchor, and it can release and reattach in under 1 second at full speed. Sailfish hits 68 miles per hour. The remora holds on, not gripping for its life, gripping by choice, repositioning mid-sprint, finding the exact spot it wants. This thing has attached to over 100 species: whale sharks, great whites, manta rays, sea turtles, whales. Researchers have found remoras living inside whale shark oral cavities, inside the mouth, riding out there in the dark while the host filter feeds. That's not hitchhiking, that's moving in. So how did one fish get so good at this? In 2022, a genetic analysis finally answered that question. And the answer was stranger than anyone expected. The remora didn't gradually develop its disc over millions of generations of slow refinement. It made one structural bet in one rapid evolutionary event, approximately 50 million years ago. A dorsal
The dorsal
fin,
fin of this
the
fish
same
begins to
fin
fold forward.
every fish has running
It
along
flattens
its
and
back,
transforms into a suction
folded
disc.
forward, flattened,
adaptation
and
allows the fish
reorganized
to cling
its
to
spines
surfaces.
into a suction grid.
The dorsal fin-
One move, irreversible, completely committed. And here's the timing that makes this unsettling. 50 million years ago is exactly when large marine predators diversified, when the ocean filled up with the giants. The remora didn't evolve in a vacuum. It evolved in response to something specific. It looked at the largest animals in the ocean and decided, I'm going with them. And for 50 million years, that has worked. Now, close the loop. Because this is the part that changes what you've been watching this whole time. The shark doesn't just tolerate the remora. Sharks carrying high parasite loads, ticks, flukes, skin infections have been observed actively slowing their swimming near remoras. Not being caught, not failing to escape. slowing down. The apex predator, the animal with no natural enemies, is presenting itself. It knows the remora is there. It knows what the remora does. And on some level, that 50 million years of co-evolution has wired in, it cooperates. This isn't parasitism. Parasites hide. Parasites avoid detection. The remora rides on the outside of a great white shark in broad daylight. What you're looking at might be the oldest active partnership in the ocean. One animal evolved a single radical tool to offer something the largest predators on Earth actually needed. And the predators, without language, without negotiation, without any conscious agreement, said yes. 50 million years of yes. So let's take stock of what the remora actually is. It's 12 to 18 inches long. No venom, no claws, no speed. In an ocean full of things that eat each other, the remora should be nothing. A snack. A footnote. Instead, it attached itself to the great white shark, the manta ray, the sailfish doing 68 miles per hour. It attached itself to over 100 different species, every apex predator in the ocean, simultaneously. One invention, one disc, and suddenly you're untouchable because everything that would eat you is now the thing you're riding. That's not luck. That's the most elegant survival strategy in the history of vertebrate life. But here's the part that doesn't leave you. Researchers have found remoras living inside the oral cavities of whale sharks, not attached to the outside, inside the mouth, swimming freely in the space behind the teeth, in the dark, while the whale shark feeds. They ride the water current the whale shark creates. They eat what the whale shark eats. They found a way to live inside the predator entirely. No weapon, no armor, no size, just a disc on its head. And the nerve to swim straight into the mouth of the largest fish on Earth and call it home. The remora didn't fight its way to the top of the food chain. It moved in,